Okay, in this problem, we're told that a substance decomposes with a rate constant of 9.05 times 10 to the minus 4 inverse seconds. And we're asked, how long does it take for 15% of the substance to decompose? Okay, so from the given information, I can tell that this is a question that will involve integrated rate laws. Now, how do I know that? Because it asks me things like, how long does it take? That's a key phrase. Or if you're talking about, the change in the amount of a substance over time, and that's talked about right here. 15% of the substance has decomposed. So those are the clues that you're looking for to know when to use integrated rate laws. And so then you need to determine, well, which integrated rate law do you need to use? Okay, now remember that you don't need to memorize the integrated rate laws. They're going to be on your equation sheet, but you're given one for each reaction order, and you need to know which one to choose to use in any given problem. All right, and so what clue do we have in this problem that tells us which one of those integrated rate laws to use? Well, in this case, it's a little bit hidden because it's hidden in the units of the rate constant, all right, that units of inverse seconds. So those units come from first order reaction kinetics, okay, and remember why. So if the rate, which has units of molarity per second, is equal to the rate constant times the concentration of one reactant with an exponent of 1, okay, that concentration has units of molarity, and so my rate constant needs to have units of 1 over seconds. Okay, so that's why. That's how I know that this is a first order reaction. So that means that I'm going to use the first order integrated rate law, which is the one with the natural logs in it. Okay, so the natural log of the reactant concentration at a given time is equal to the negative of the rate constant times time plus the natural log of the reactant concentration initial. Okay, so let me just write that down so we can work with it. So the natural log of some reactant concentration at a given time is equal to the negative of the rate constant times time plus the natural log of the initial reactant concentration. All right, so we're going to solve for time. Okay, we're asked, how long does it take? So I want to go ahead and rearrange and solve for time. So the first thing I need to do is get rid of this plus natural log of the initial reactant concentration. So I'll subtract that from each side. And so you get the natural log of the reactant concentration at some certain time minus the natural log of the initial reactant concentration. Okay? And the other thing I'm going to do is I'm going to divide both sides by negative rate constant so that I get rid of this. So I'm going to divide that by the negative k, and so that isolates the time. Okay, so that's kind of the next thing to do in a problem like this, is rearrange and solve for the variable that you're looking for. Now the last thing you need to do is plug in numbers. And in this particular problem, it's not real evident what those numbers need to be, because it just says how long does it take for 15% of the substance to decompose. Okay, so all we're told is that it's a certain amount of time for 15% of this stuff to decompose. So what numbers should I put in here to represent that? Well, it's easiest if you think of this as like, 15 out of 100. So our initial could be 100. So our initial concentration is just going to be 100. Okay, and then the concentration at some later point in time is just 15 less than 100. So that's 85. Okay, and then we're going to divide by the rate constant, which is we're given, the negative of the rate constant, which we're given, 9.05 times 10 to the minus 4th inverse seconds, and that equals some amount of time. Okay, now I'll just, spoiler alert, I'll just go straight to the, you plug all that into your calculator, and you get that the time is 180 seconds.